All right, moving on to the second part. We're going to talk about how to take, just like we did up here where we put them all together. It's like, let's pretend it's a sweater. We had an unknit sweater and we put it together into one. Down here, we're going to take a single log and we're going to make it into a few of them by expanding them. All right, so it's like we're pulling the sweater apart. Now, the first thing to determine is that every log is going to have a base of 3. The next thing is that you are going to have 3 separate logs. You're going to have a log for the 2, a log for the x, and a log for the y. So I'm going to write log base 3 with a 2, log base 3 with an x, and log base 3 with a y. Now let's go ahead. So I've taken care of this, and this. I have my log base 3. Every single one of them is going to have an exponent of 3, a coefficient of 3 in the front. And it was all multiplication, so they're all addition. So because this was multiplication, over here they all become addition. The last thing you could do, and really that's not so bad, you could take this 3 and make it an exponent on your 2. So this particular logarithm could actually be rewritten as log base 3 of 8, because 2 to the third. Now, if you wanted to, you could put that 3, no, not in Spanish form, they want you to keep that 3 down there. I was going to say, really that 3 is an exponent on the x, but we're going to keep it down in front in expanded form. The only reason I put it on the 2 is because you can like do 2 to the third and make it a number. All right, this particular log, the next one, is going to have a log base 2, and it's going to have a log base 2 for the 3, the x, the 8, and the y. So log base 2, how many was that? 3x, 8, and y, that's 4 of them. So I'm going to cheat. I'm going to go duplicate. There's 1, 2, and 3 and 4. So there's 4 of them. The first one's going to be for the 3. The next one's going to be for the x. The next one's going to be for the 8. And the last one will be for the y. Now the only thing I haven't touched yet is this 3. That 3 is an exponent on the y. So let's go put it on the y. There it is. But it doesn't, in expanded form, we really should take that 3 and put it in front instead. I'm going to make it a little bigger so it doesn't look like an exponent anymore. There you go. Now, the 8 and the y were in the denominator, right? You see down there how they were in the denominator? That means their logarithms need to be negative. Everything else is positive because it was in the numerator or multiplication. So anything that's in the denominator becomes negative. Here you go, here and here, the 8 and the y. And last, we have this log base 5. Can you guess how many log base 5s we're going to have? 1 for the 2, 1 for the a, and 1 for the b. So there's 1, there's 2, and 3. 1 for the 2, 1 for the a, and 1 for the b. All of this was multiplication over here, so all of these are adding. There's no outside number to deal with, and there's no exponents inside, so that is your answer. And that's how you expand logarithms.